Hello everyone. Today I'll be going over problem 10 from Controls Homework, and in this problem we have to sketch a root locus, and we are given an open loop transfer function to do that. So to start off with, you mark your poles and zeros from the uh, transfer function that is given to you, and you can put those points, such as your poles and zeros, on the plot to kind of give you an idea where you're going to be going with this plot. So your zeros are going to be -2 and plus minus 2j, because if you look at the numerator, you have +2 and s squared plus 4. So you know your 0 is going to be -2 plus minus 2j. And your poles are going to be -5 and plus 3. So you know that one pole is on right hand side. Um, so this should tell you that the plot is going to look kind of weird. So you want to know some other things about it, so you can kind of deduce, like, okay, well, I have an idea what this plot is going to look like. So to help with that, you're going to have to do some more calculations. So first off, you have to find your asymptotes. Now, to do that, there's an equation. It's 2k plus 1 times pi divided by number of poles minus number of zeros. And with this equation, you assume value for k. And for this, I assume the value for k to be 0, and that gives you -pi. So it tells you that uh, the value for the asymptote. Now, to find the center of asymptote, you would use the formula, which is the sum of poles minus the sum of zeros divided by number of poles minus number of zeros. And the numerator actually equals up to 0. So you know that this value is going to be um, -pi 0, telling you that it's on x-axis, and that tells you that you're going to have to find your breakaway and break-in points. Now, to do that, there's an equation that you would have to use to set it up, which is 1 plus gs times h of s equals 0. So as you could see, that there's a +1 on in this equation, and if you bring that on the right hand side, that would be -1. And that's why if you look on this side, you could see why this equation looks like that. So just do some algebra to solve this, and you're going to replace s with this symbol right here. I'm sorry, I don't know the name for this symbol, but you replace s with this symbol. Um, and once you have it in that form, you would have to take the derivative of this. Now, this is quotient rule, but don't worry about the denominator, because it's going to cancel out because of the 0 on the right hand side. So just worry about the calculation for the numerator. Don't worry about the denominator because it's going to cancel out. So do some arithmetic, and you would have maybe a good or maybe an ugly looking equation for which you would have to find the roots. Once you find the roots, you would have to find the angle of arrival. Um, and again, this is all plug each other. You just take your formula and plug in the values that you have. Now for this one, the angle of arrival comes out to be 213.11, telling you that's in the third quadrant. Um, to be sure that how a root locus kind of looks like, I mean, you can kind of find out like what it's gonna be. I'm just gonna use a software tool to see how it does. So let's see. Hmm. Okay, so as you can see right here, with this program, I can I can have an idea that what it's gonna look like, and let's see if I can see my. Now, as you can see, I have my numerator denominator put in. Let's see. and show me my plot. Okay, right there. All right, let me move the screen back. So if you see right there, it tells you that the plot is going to have this type of kind of shape to it. And of course, since you know that this is going to connect at your point as you were looking at the break-in and breakaway points, so this line here is going to connect this. And let me go back to our plot. And that kind of gives you the idea that it's going to connect at this break and breakaway point, giving you the shape what the root locus is going to look like. And I think they ask you to find the gain k value. To do that, you multiplied your values you found for your poles and zeros, and in our case, um, the poles are 3 and 5, and your zeros are going to be 2, 2, and you have 3 zeros, so it's going to be 2 times 2 times 2, which is going to give you 8. So k, it tells you that 15 over 8 is less than k. I hope this problem helps you. Thank you.